Okay, so I am going to come back to this example here, my check your understanding to B, because I made a boo-boo. So what I forgot to do when I multiplied right in here, where's my magic pen? When I multiplied in here, I forgot to go x times negative 5 is negative 5x. So that changes a lot of things. So this has an x, this has an x. So it's going to change our answer a little bit. So I'm going to move this over here. So I needed to add 5x. So what I'm really getting is negative 1x plus 2x plus 5x is, oh shoot. Let's just see what that is. So negative 1 plus 2 is 1 plus 5 is 6. So I get 6x minus 2 equals 0. So I'm going to add 2 to both sides. So I get 6x is equal to 2. Divide by 6. When I do that, I get the reduced fraction of 1/3. So you can just go 2 divided by 6, math 1 it. So that looks like a better answer. That is not a non-permissible value, so double negative. This is the real answer. Sorry about that. Hopefully you're like, wait, Miss Allen, when I was doing that the first time, but I know I zipped through it pretty quick. Okay, so C. So first thing I want to do is put brackets around my numerators and denominators. And we're going to add one more step to the beginning. So what I want to do before I find my non-permissible values is see if I can factor any of our numerators or any of our denominators first. So if I look at 7x minus 15, the only way I could factor that is if I could take a common factor out of there, but there's nothing that divides 7 and 15 besides 1, so we're just going to leave that. So I'm going to look at my denominator of x squared minus 9. We can factor that. That follows our a squared minus b squared rule. So x squared minus 9 is really x plus 3, x minus 3. And then x, so our next numerator, x minus 2, it's already broken down as much as it can be. Same with x minus 3. So what I'm going to do is rewrite my expression with my new numerators and denominators. But in this case, we only have one new denominator. Okay, and now I'm going to follow my steps. I'm going to find my non-permissible values. So x plus 3 can't be 0, so that means x can't be negative 3. X minus 3 can't be 0, so x can't be 3. And then our other numerator is x minus 3, which I've already taken care of. So we know x can't be negative 3, x can't be 3. Now I'm going to find my lowest common denominator. So I know x plus 3, x minus 3. And then for the right side, I've already written down x minus 3. So now what I'm going to do is multiply everything by my lowest common denominator. So I have 7x minus 15, and that's over x plus 3, x minus 3, and I'm going to multiply that by my lowest common denominator. And then this is equal to x minus 2 over x minus 3, and I'm going to multiply that by my lowest common denominator. Okay, now I can cross things off. So my x plus 3's go away, my x minus 3's go away, woo, and then my x minus 3's go away. So I'm not going to rewrite this. I'm just going to manipulate this a bit. So the only thing left on the left side is 7x minus 15. On the right side, I have this x minus 2, x plus 3. I'm going to FOIL that out, multiply it out. So when I do that, I get x squared plus 3x minus 2x minus 6. Okay, so here my x squareds don't go away, so I'm going to move everything to one side and then factor. So I'm going to subtract 7x from both sides. I'm going to add 15 to both sides. And when I do that, I get 0 is equal to x squared. Okay, 3x minus 2x is 1x, minus 7x is negative 6x. Negative 6 plus 15 is 9. And I'm just checking my book to see if that's what we should get. Yes. Okay. And then I'm going to factor that. So my first one is x minus. What times a minus makes a plus? Another minus. I need two numbers that multiply to 9. Those same two numbers add to 6. You might want to pause here because I'm going to spoil the surprise of what those two numbers are. They are 3 and 3. So the big one goes in the first bracket, the small one goes in the second bracket, but they both happen to be the same. So what this is telling us is that x minus 3 is 0. So that says x. Oops, just like that. Okay, so that's saying that x is 3. So I need to check this with my non-permissible values. Okay, and then our non-permissible values, they say that x can't be negative 3, x can't be 3. So this one specifically, okay, we figured out that x is equal to 3, but it's not allowed to be. So what this means is even if we solve this, we got x is equal to 3. We can't have that. Whoops, I won't do that in the magic pen. We can't have that. That's not allowed. So what this answer is called is this is called an extraneous root. Okay, it means we found an answer algebraically, but because we were manipulating things like denominators and stuff and getting rid of it, it means even though we solved and we got that answer, we can't put that back into our original equation or else we're dividing by 0 and then our calculator smacks us in the face. So this is an extraneous root. Because that's the only answer we got and that's not allowed, that means this has no solution. So if you're given this equation, there's no x you can put in there to solve this thing. It can never happen. So you'd never see this in real life. Yeah, so that's what I have to say about that one. Okay, let's look at, now we're looking at check your understanding. Number 3. So same old steps here, just a little bit more complication here. So want to put brackets around my numerators and denominators. And then what we normally do is find our non-permissible values, our lowest common denominator. But before I do that, I want to factor any numerators and denominators that I can. So negative 10, well, I'm not going to factor that. I will factor my x squared minus 12x plus 35. Okay, so x minus, what times a minus makes a plus is a minus. So I need two numbers that multiply together to give 35. Those same two numbers add to 12. Pause here to figure them out. They are 7 and 5, so 7 goes in the first one, 5 goes in the second one. So I'm going to rewrite my equation. Oh, sorry. I can't factor x. I can't factor x minus 5. So I'm going to rewrite my equation with my new numerators and denominators. But in this case, again, we just have one new denominator. Okay, now I'm going to find my non-permissible values. So x minus 7 can't be 0, so x can't be 7. X minus 5 can't be 0, so x can't be 5. And then we have x minus 5 again, so that's good. Okay, my lowest common denominator is x minus 7, x minus 5, and then x minus 5, but we already wrote it down, so we're good. Now I'm going to multiply everything by my lowest common denominator. So I have negative 10 over x minus 7, x minus 5. I'm multiplying that by x minus 7, x minus 5. That's equal to x over x minus 5. And I'm multiplying that by x minus 7, x minus 5. Okay, so my x minus 7's cross off, my x minus 5's cross off, and then on the other side, my x minus 5's cross off. So what I am left with is negative 10 is equal to, and I'm just going to multiply this out. So I get x squared minus 7x. Okay, so because I have, I'm just going to move this, because I have a x squared, I want everything on one side, and then I'm going to factor that. Those go away, so 0 is equal to x squared minus 7x plus 10. So if x minus, what times a minus makes a plus a minus? I need two numbers that make 10. Those same two numbers add to 7. Pause here, figure them out. There are 5 and 2. Big one goes in the first bracket, small one goes in the second bracket. So that tells us x minus 5 is 0 or x minus 2 is 0. So x is equal to 5 or x is equal to 2. And we're going to see if we have any extraneous roots. So I need to check those with my non-permissible values. So we're told that x can't be 5. Okay, so that answer is not okay. So we're going to get rid of it. Bye-bye. So our only answer that's okay is x is equal to 2. Okay. So we will do B in the next video. See you there.